Els, vanmorgen begin ons met Euklidies. En kom ons begin, ons Euclidiese meetkunde in graad 11 is all about circles. So let's start with the basic knowledge about circles. Kom ons gaan kyk gou. 'n Sirkel het 'n middelpunt. Waar is sy middelpunt? Ons kan hom sommer die middelpunt O noem. Ons noem hom gewoonlik die middelpunt O. Then we can have points on the perimeter, like this. Ons kan hierdie dan ook ABC noem, ons kan dit dan ook sirkel ABC. Goed, dan weet ons dat 'n sirkel het 'n radius. 'n radius is the line that's from the midpoint up to a point on the perimeter. En dat maak nie saak waar ek hom trek nie, alle radiusse is ewe lank. All radiuses are equal in size. If I take the radius and I draw the radius and lengthen it through the midpoint to the other side of the perimeter, then we've got a diameter, a middellyn. Goed, baie belangrik dat ek dit moet weet. Dan kan ek ook 'n lyn trek van een punt tot by 'n ander punt, soos byvoorbeeld BP. And this line that I've drawn over here is a chord, 'n koord. Belangrik dat ek dit moet weet. Hierdie stukkie wat ons dan nou hier sien, daardie stukkie, soos wanneer 'n stukkie van 'n koek sal afsny, daar op die randjie, noem ons 'n segment. That's a segment, this piece. Okay, is a segment, there's a small segment, and that's a big segment. Maar julle ding is 'n groot segment, klein segment. Dan kan ons verder gaan kyk, goed, ons weet daar is 'n koord, klein segment, groot segment. Hierdie ronding van die sirkel, byvoorbeeld van A na B, noem ons 'n boog. That's an arc from this round line from A to B is an arc. And the last thing that we must know, if we draw a line that touches the circle at one specific point, let's name that point Q, if that line touches the circle at one coordinate, then that line is a tangent. Hierdie lyn wat die sirkel raak by een punt is 'n raaklyn. So ons moet al hierdie goed weet. Middelpunt, radius, middellyn, I've got a chord there, arc there, tangent there. This is points on the perimeter of the circle, and that's a segment and a big segment. Goed, 'n bietjie terminologie. Okay, I'm going to use this circle to do an example just now after I've done theorem number 1. So let's just quickly see what we need. I'm going to take that piece out. Okay, en ek gaan hierdie goedjies uithaal. Alles uithaal, and I'm going to do an example on this circle. Just now. Okay, goed. Kom ons gaan kyk dan na ons heel eerste stelling wat ons in graad 11 moet ken. And this is theorem 1. We must know the physical proof of the theorem. Ons moet stelling 1 moet ons kan bewys. Wat beteken dit? En juffrou het dit al oor en oor vir julle gesê. Dit beteken dat wanneer daar vir my gevra word, bewys dat die loodlyn uit die middelpunt van die sirkel na die koord halveer, dan moet ek die skets self kan teken as daar nie 'n skets vir my gegee is nie. And I must be able to do the whole theorem. And I'll go through the steps just now. Goed, luister mooi. When it's being asked to prove the theorem, the line from the midpoint of the circle that's perpendicular on the chord, halves the chord, then you need to be able to draw the sketch yourself, if a sketch is not provided, and you must be able to write out the whole theorem. So kom ons begin nou, en juffrou gaan presies vir jou wys, hoe skryf ons die hele stelling uit. Just get there. Okay, the first thing that you must write down is what's been given. Okay, what's been given. Let's start there. Wat is vir jou gegee? What's been given? So you start, you draw the sketch, and then you say, write down, what's been given? Okay, there's a circle, midpoint, a circle with a midpoint, O, a chord AB, and then a point B on AB, so that OP are perpendicular on AB. That's everything that's been given. Gaan daar deur, 'n sirkel middelpunt O met 'n koord AB, punt P op koord AB sodat OP loodreg is op AB. Dit is gegee. So, wat moet jy bewys? To prove, you write this out, everything exactly as I do it. To prove, you must prove that AP are equal to PB. So if you look at the two sketches, I've now drawn the sketch that we're going to use to prove this, and we must go there to this sketch. Jy hoef nie hierdie gedeelte, jy verwys maar net, jy moet net hierdie skets teken. Maar ons is op pad soontoe. Ons wil dit graag bewys. Okay. So wat gaan ons doen? So you only draw this sketch, I've just drawn that one to show you that theorem 1, the forward one, is from there to there. Goed. First thing that we need to do in our proof now is we must make a construction. En jy skryf daar konstruksie. Okay. Jou konstruksie wat jy maak is jy verbind OA en OB. So now you show your construction in your sketch 2 by doing this. You show it in the sketch and you write it in words. As jy dit nie in woorde skryf nie en dit ook nie op jou skets wys nie, dan kry jy 0 vir jou stelling. So that's very, very important. Now we can start our proof. So we are going to do congruency in triangle AOP and triangle BOP. Double point. Number 1. We know that OA equals OB. Why? It's radii. Dan weet ons ook dat OP gelyk is aan OP. That's a common side. And the last thing that we know is that, and when you do this, you need to go and put in a 1 and a 2 if there's two angles formed by points. So jy kan ook sê, P1 is gelyk aan P2 is gelyk aan 90 grade, angles on a straight line. Angles on a straight line. Now I've proven 90-degree hypotenuse side. Therefore, triangle AOP, en nou as ek die kongruensie neerskryf graad 11, moet ek seker maak dat A gaan saam met, hoek A gaan saam met hoek B, so ek skryf hom eerste. Hoek O gaan saam met hoek O. En hoek P gaan saam met hoek P. So I must write it correctly. It's a coincidence that I've written it correctly there at the top. But at the end, it must be, things that goes together must be written in order. So ek gaan sê, dis 90 grade, skyn sy. And now I've proven this to triangles, identical, congruent, and now I can make my conclusion. Therefore, AP equals BP, and the reason why I can say that is because triangle AOP is congruent to triangle BOP. And I've proven my theorem number 1. Jy moet dit presies so doen, jy moet die skets gaan teken, nie daai ene nie. That's what I've now proven. Jy moet jou konstruksie skryf en inteken, and then you've got to do the proof. And that's a beautiful congruency proof that you've studied in grade 9 already. As ons gaan kyk na die omgekeerde van stelling 1, dan hoef ons nie die omgekeerde stelling se bewys te ken nie. It's not necessary to write out the proof. So all that you need to know is that the reverse of this theorem number 1 is a line that connects the midpoint of a circle with the midpoint of a chord is perpendicular on a chord. Dit is al wat jy moet weet. 'n Lyn wat die middelpunt van die sirkel met die middelpunt van die koord verbind, is loodreg op die koord. You need to know that. So if you see this in a sketch, your reason is going to be the reverse of line, midpoint of circle to midpoint of chord, perpendicular on chord. Okay, you need to write the word reverse. So now, with this in your back end, I'm going to do an example. And I'm going to make some space over here. So let's make some space. And I'm going to do our first example where we're going to use all our previous knowledge. So let's see. I've got a chord AB. There in your circle. Then we've got a line from that chord to another chord CD. Okay, this, let's name this one P1, P2, and AP equals PB. Dit is gegee. Dis my middelpunt O, en hierso het ek 'n radius AO, en ek het ook 'n radius OC. En dan het ek ook hierso 'n 90-degree angle, and that's Q1 and 2. So let's see what's being asked. Good. Let's say I've got a circle, midpoint O. I see that AP equals PB. I see that Q1 equals 90 degrees. Therefore, CD is perpendicular on OQ. AB is 6 cm lank. So hierdie koord is 6 cm lank. CD is 8 cm lank, so daai koord is 8 cm lank. And the radius is 5 cm. The radius equals 5 cm. So the first question is, determine the length of OP and PQ. Bepaal die lengte van OP en PQ. Goed, dit is dan maklik. So ons weet dat AP is gelyk aan PB. Okay, because that's given. Dis gegee. En daarom is hulle ook gelyk aan, as daai 6 cm is, jy kan sommer daar wys, dit is 3 cm. Dan weet ons ook, dat OA is gelyk aan 5 cm, that's also been given. So now we can see that we've got a beautiful Pythagorean triangle over there, so it's easy for us now just to simply calculate OP with Pythagoras. So we've got, okay, now we can't use Pythagoras yet. We first got to say that P1 equals 90 degrees out of our theorem 1. We've got to say that first. Although we know it, we must write that down. The reason for that is the midpoint of the circle on the midpoint of the chord. Theorem number 1. Midpoint. Now, theorem number 2. It's the reverse of theorem number 1. Middelpunt van die sirkel op die middelpunt van die koord maak hom loodreg. Good. Okay, now we can use Pythagoras by saying that I want to get OP square. That's going to be the hypotenuse square minus vir AP. En dit is Pythagoras wat so gesê het. Remember, you must also always give a reason. So now we can do substitution. OA is 5 square minus 3 square. That's going to be 25 minus 9. En dit gee vir my 16. En daarom is OP gelyk aan 4 centimeters. So I've got OP. Now we're going to look at PQ. Kom ons kyk. PQ. Okay. We need now to get this piece as well and add it to get to that piece to get PQ. So kom ons gaan kyk. Ons weet dat CQ is gelyk aan. Okay, let's start with CQ equals QD. Why? That's theorem number 1. That's sy loodlyn uit middelpunt halfveer koord. Okay, so now we can say, therefore, CQ and QD both equals 4 centimeters. Okay, we know that OC also equals 5 centimeters because that's a radius. That's a radius. Now, we can use Pythagoras again. Okay, let's go on over there. We can use Pythagoras again to determine the length of OQ. So we've got OQ square is going to be OC square minus QC square. So ons het vir OC, hy's 5 cm en ons het vir QC, hy's 4 cm. So now I've got 25 minus 16, that's going to give me 9, and therefore OQ equals 3 centimeters. So as ons nou vir PQ wil hê, dan gaan tel ons vir OQ en OP bymekaar, en dit gee vir my 7 centimeter. The next question is, explain why AB are parallel to CD. Explain why AB are parallel to CD. Hoekom is daai twee lyne ewewydig aan mekaar? Want as ons gaan kyk na hierdie twee hoekies. I'm going to explain this to you. Because P1, I've proven P1 as 90 degrees. That's been given as 90 degrees, so you can answer it as follows. B. P1 equals 90 degrees, proven. Q1 equals 90 degrees, given. And therefore, AB are parallel to CD. And my reason for that is co-interior angles. Co-binnehoeke, as co-binnehoeke saam 180 grade is daar die twee lyne ewewydig. So there, grade 11s, I've applied my theorems and my previous knowledge to solve a problem. I'll be back with theorem number 2.